Okay, linear equations in 3 variables. This is 3.4. What is a linear equation in 3 variables? It has a form something times x plus something times y plus something times z equals some number or some constant. What's a system of those? Well, if we have 3 variables, then we need 3 equations to solve that. So you have to have 3 equations. And the answer to those 3 equations is the values of x, y, and z that makes each equation true. We call that the solution. We call it an ordered triple this time because there are 3 values, x, y, and z value. Okay, using the elimination. This is about the same as elimination for a 2-variable equation, except we have to do it over again for the 3rd variable. So step 1, we're going to rewrite that linear system in 3 variables, or as a linear system in 2 variables. So we're going to eliminate one of those variables. And then we're going to solve for both of its variables, and then substitute the values found back in step 2 to solve for the remaining variable. You obtain a false equation, such as 0 equals 1 in any of the steps, then this system has no solution. Just go back and make sure you didn't make a math error during this. If you do not attain a false equation, but attain an identity, such as 0 equals 0, an always true thing, then the system has many solutions. Okay, let's try one of these. These are really long, and there's actually a better way to solve these, but we need to learn how to do at least one by hand. So, solve the system. I have equation 1, 2, and 3 over here, and I'm going to choose, look and grab 2 of these equations that I can solve real fast and get rid of a variable. Let me choose equation 1. 3x minus 2y plus 4z equals 20. And then I'm going to choose equation 3. But when I write down equation 3, do you see if I take this and multiply by negative 3, I can eliminate the x? So let me do that as I write it down. So I'll have negative 3x minus 9y plus 6z equals negative 3. Adding down, I'll have negative 11y plus 10z equals 17. Now, right here you would say, I haven't gotten anywhere because I still don't know what one of the variables is. And that's true. So right here we're kind of stuck. But because we had 3 equations, I need to go ahead and get rid of x in another 2 equations, and then I can work with both of these revised equations together. If you don't understand that, just hang with me. It's not really that bad. So I'm going to move this up a little bit, have more room to write. And what other equations do I want to use? Okay, there's kind of a method to this. So I need to choose one of my equations that I used up here, either 1 or 3, with the one I didn't use over here, 2. So looking at 1 and 3, and then 2, what would be easiest to use? Well, if I took off this times 3, which is not going to let me do for some reason. Okay, if I took off this times 3, then scribble over it. You know, if I just add down, I would eliminate the x's. So let's do that. So I'm going to rewrite equation 2. And then x plus 3y minus 2z equals 1. Okay, I'm going to add down to get 8y plus 10z equals 74. Okay. Now, I have 2 revised equations, and I need to manipulate those to get rid of one more variable. So, let's try that. Let me change colors once again. And rewrite the 2 equations next to each other. So negative 11y plus 10z equals 17. Then we had 8y plus 10z equals 74. What would be the easiest to get rid of? Well, the z's, right? Because all I have to do is flip the sign on the second one, and I can add down. So let me do that. Multiply everything in here by a negative. So that'll give me negative 8. And then that would give me minus 10z and negative 74. So when I add down, I'll have negative 19y equals negative 57. Okay, if I divide that out, so divide both sides by negative 19, I'll have a positive 3. Yay, we have one variable. But I still need to know what x and z is. So I need to go back up here to my original equations. Or not even all the way up to my original equations. Let's just look at these 2 equations right here and plug my 3 in. So I'll have negative 11 times 3 plus 10z equals 17. Or I could have put it in the second one. It didn't really matter as long as I did all the math right up to this point. So that'll get me negative 33 plus 10z equals 17. Add 33 to both sides. So 10z equals 50. So z equals 5. Well, I still don't have x, but that's okay because x is pretty easy to find. So I do need to go back, though, to my original equation up here. And plug in the values that I know now. So I am looking for x. I know that y was 3, so I'm going to substitute 3 in for this y. And I know that z is 5. and that equaled 20. So now 3x minus 6 plus 20 equals 20. If I subtracted 20 from both sides, I will get 3x minus 6 equals 0. Add the 6, 3x equals 6, so x equals 2. Yay! Now that's still not my whole answer. For my whole answer, I need to put all of these into a triple and say that x is 2, y is 3, and z is 5. And that is my solution. Like I said, these are long. And like I said, they're not very fun. There's a better way to do it. But you need to know how to do these by hand, just knowledge-wise, so you know what your calculator will do. Okay, let's look at your checkpoint here. And let's talk about how to do this checkpoint. What I would do first is take these two equations and add them down. You should get x plus 11z equals negative 8. And then take these two equations, multiply this one by 2. No, you don't want to do that because that would get rid of the x. You need to get rid of the same variable that you got rid of the first time. So let's take those two equations now, multiply this one by 3. So rewrite that one real fast. 4x minus 3y plus 5z equals negative 19. And then multiplied by 3, there it is negative 6x plus 3y plus 9z equals 39. Add those down, and then you'll have these two equations that you can use as a regular elimination and get rid of another variable, like x, and you'll find z. Then go back, substitute the variable you find, and get the other variable's number, and then take those two, come back up here, substitute those two variables in, and get the last one. So, I know this is a little bit confusing. I want you to try though, okay? Okay, let's try one of these that has no solution. So, I'm going to pretend I don't know this doesn't have any solution and work it out. They chose equation 1 to start with. And then what do they do? They are going to multiply the second equation by negative 2. So that would give me negative 2x minus 4y minus 10z equals 8. When I add these two down, I'll get 0 because all of these cancel, don't they? 0 equals 22. And you know that's a false solution. That can never be true. So the original system has no solution. Okay, solve a linear system with many solutions. Okay, and I'm not actually going to go through this all, but I am going to show you something real fast. If I take this first equation and multiply by 2, that would give me 4x minus 4y plus 8z equals 12. Okay. And I'm actually I thought I could show you something with that, but I'm not going to, because this is just something that you really wouldn't do. So just know that some of these have many solutions, but you're not going to be asked to find those this year. You probably will in college algebra. So let's just end that here. And I do want you to be able to do those, like the first checkpoint, that have one solution to them. And then take a look down here at, or on the next page, on the checkpoint down here. This one has no solution. So I want you to go ahead and start this one and see if you can work it out so you can see that it has no solution. Okay? You don't have to do this.